Islands have edges. Planets have edges. Even galaxies have edges. But what about the universe?
As explorers, as curious humans that we are, we're obsessed with boundaries and limits, and we want to know, does the whole thing, the universe, have a limit?
Does the universe have an edge? Well, the answer is yes and no. It depends on what you mean by edge.
The edge of what we can see. The edge of where we can go. Or the edge of reality itself.
Looking out to the edge of the universe is tremendously important to understand our place in the universe itself.
We're talking about our universe. We're talking about the thing that we exist within, the most fundamental thing there is. We're driven to understand it.
There's always a desire to push the knowledge to the edge.
So can we ever find the edge of the universe? In 2016, the Hubble Space Telescope turned toward a dark patch of sky in the constellation Ursa Major. It captured an image of an indistinct blob of light. The glow is from a distant galaxy called GNZ 11. It's the most distant galaxy we've ever observed. But is it the edge of the universe?
The universe all around us is filled with galaxies, so it's kind of natural to say, would there be a final galaxy? If you traveled far enough away, would you finally be at the very last galaxy in the universe looking out into empty space?
That's a difficult question to answer, because there is a limit to how far we can see. It all comes down to the speed of light and the age of the universe.
The key to understanding the edge of the universe is that light travels very, very fast, but not infinitely fast. It takes time for it to get from one place in the universe to the other.
You open the curtains, light fills the room. It doesn't seem to travel at all. But over the vast distances of the universe, you actually notice this travel time. Even the sun, 93 million miles away, the light takes 8 minutes to get to us.
When you look out at the stars, we start to think of distance in terms of light years, because it takes years for the light to get from those stars to us. And then when you look at galaxies, then you're talking about millions or billions of light years.
When we look at light from galaxy GNZ 11, we're seeing light emitted 13.4 billion years ago. It's a bit like looking deep into the Earth.
What we do in geology is we look at the layers of rock like a book. And as we move down in those layers, we're moving through the book's history, going deeper and deeper and deeper in time. We see whole ecosystems that were different than they are now. Ecosystems with unfamiliar animals, atmospheric gas concentrations that were different. Things work differently.
But there's a limit to how far back in time we can look.
We look at these various layers of rocks and we go older and older and older in those rocks and lower and lower and lower in the sequence. We ultimately reach a limit about 3.6 or so billion years ago, before which there weren't really any rocks at all on the Earth. And so there's a finite place that we can measure to. And it's very similar looking out at the cosmos.
The Hubble Space Telescope has snapped an image of GNZ 11. It is the earliest and most distant galaxy we've ever seen.
The story in our understanding of the cosmos has been one of pushing outward on boundaries at all times, right? The frontiers of discovering our universe are very, very distant and getting further away every day. We are pushing further and deeper into the past toward the earlier edges of our universe.
And now NASA is building an even more powerful observatory, the James Webb Space Telescope.
When the James Webb Space Telescope launches, it will witness the birth of stars nearly at the edge of time itself. So we're pushing outward, we're learning vastly more about the earliest days of our universe. And it's a really exciting time to be in astronomy.
The James Webb Space Telescope has the capacity to spot earlier and more distant galaxies than GNZ 11. But there's bad news.
You can't really even find a galaxy too much farther away than that because the universe is only 13.8 billion years old, and it takes a certain amount of time for galaxies to even form. So we're not going to find too many more galaxies farther away than this.
If things are far enough away, there is no way that light can get to us in the age of the universe. What this means is there's a hard limit to the edge of the universe that we can see, and this is set by the age of the universe.
GNZ 11 sparked into life early in the history of the universe, just 400 million years after the Big Bang. Before that, there were no stars to send out light.
If you look in any direction at all, you get all the way back to when there were no stars, no galaxies, nothing but very, very hot gas. And that sort of forms a shell around us.
That outer shell is the cosmic microwave background. It's the oldest light in the universe, the echo of the birth of the universe, the Big Bang.
The edge of our universe, the very furthest thing that we can see, is one of the earliest relics of the formation of the universe itself. That is the cosmic microwave background.
We call this the edge of our observable universe.
So we have an observable universe, but beyond that, even if there are things out there, there's no way we can see them because the light just could not have gotten to us by now.
As the name states, the observable universe is simply the part of the universe we can see.
We can think of the observable universe as sort of like a spotlight centered on wherever you're standing right now, and you can see to the edge of your spotlight and not beyond. But if you move a little bit to the left, a little bit to the right, your observable universe actually moves with you.
For someone living in galaxy GNZ 11, a totally different part of the universe would be observable.
So that distant galaxy is at the edge of our observable universe, and we are at the edge of their observable universe. We have different spotlights.
One of the wonderful things to think about is that there are other spheres around other galaxies. There are other aliens looking up into the sky tonight, wondering what the true extent of the universe is.
The true extent of our universe doesn't end with galaxy GNZ 11. But when astronomers use the Hubble Space Telescope to measure the distance to GNZ 11, they find something shocking. It's 32 billion light years away, 3 times further than thought possible.
So if nothing can travel faster than light, and we measure the distance to this galaxy, how can it be 32 billion light years away?
There hasn't been enough time in the history of the universe for light from GNZ 11 to reach us. There must be some mistake here, right?
At this point, your brain is probably thinking of leaping out of your skull and running around screaming. Trust me, I know. I'm an astronomer. I've been doing this my whole life, and this stuff twists my imagination up. It's really hard to grasp this.
How do we see a galaxy that's 32 billion light years away and only 13.4 billion years old?
GNZ 11 is further away than it should be. Because something strange is going on with our universe. It's expanding. If the universe is expanding, then where does its edge lie? And can we ever reach it? $13.8 billion years ago, a speck of energy burst into life. We call it the Big Bang. Space and time pushed out in all directions. Ever since, our universe has expanded. But the way it's expanding makes finding an edge a major challenge.
The universe is expanding, and expands according to a very simple law, that the farther away a galaxy is from us, the faster it appears to be receding away from us.
The furthest galaxies are moving at very high speeds. The most distant galaxy we've ever spotted, GNZ 11, seems to have moved 32 billion light years away from us in just 13.4 billion years. That's faster than the speed of light.
We can measure the speeds with which galaxies are moving away from us. And many, many galaxies are moving away from us at speeds faster than the speed of light. This sounds like it's breaking the law, right?
There's this idea that you've all been told that relativity says nothing goes faster than the speed of light. Okay, you've been lied to.
Space itself can do what it wants. It makes the rules, it can break the rules. That rule applies to matter, not to space itself. Space can expand at whatever rate it wants.
A simple way to think of this expansion law is imagine standing on an infinite rubber sheet that stretches all the way out into the distance, and you're standing on the same place. You can mark it with a little X. Now, all the sheet expands in every direction. So if it expands by a factor of 2, another galaxy that was, say, 1 foot away from you is now 2 feet away from you as we stretch the sheet. But another galaxy was 10 feet away from you. Expand that by a factor of 2, and now it's 20 feet away from you. So in the same amount of time, one galaxy moved 1 foot, where another galaxy moved 10 feet. So the more stuff there is, the more elastic between you and another galaxy, the more it seems to expand away from you.
Expansion means our observable universe stretches for a colossal 46 billion light years in all directions, 92 billion light years across, and getting bigger by the second.
This number is so incomprehensibly large that it's difficult to wrap your brain around. There are trillions of galaxies within this volume. It's staggering. It's so much larger than anything we're familiar with.
If we were to travel to the edge of the observable universe, we would enter even more unfamiliar territory. Imagine we're in an ultra-fast spaceship. We leave the solar system, then the Milky Way. As we travel deeper into intergalactic space, things start to get really weird. For every million light years we go from the Milky Way, the galaxies move away from us at around 13 miles per second faster. We have to accelerate just to keep up, but the galaxies keep on moving, always beyond our reach.
Imagine you're a sprinter on a racetrack. If you're running towards the finish line, it may take you a few seconds to cross it. But now imagine that that finish line is moving away from you. If it's moving away from you at the same speed you're running, you'll never reach it. And if it's moving faster than the runner, then even faster runners won't reach it. And that's sort of what we're seeing here with the universe.
Beyond a certain distance, galaxies are racing away from us faster than the speed of light. It's a line called the cosmic event horizon. And 97% of galaxies we see in the observable universe are beyond this line and unreachable, including GNZ 11.
They're sort of teasing us to say, look at me, what a nice piece of real estate. But we know even if we started going there now, we could never reach them.
Anything that has crossed the cosmic event horizon is out of our reach forever. But that's not the full picture, because the expansion rate of the universe is changing.
A little over 20 years ago, astronomers discovered that the current rate of the universe's expansion is accelerating. It's speeding up. Everyone thought that the expansion of the universe should be slowing down because of gravity. Galaxies have mass, they have visible matter, dark matter, light has energy as well. All known forms of energy slow down the expansion of the universe because they act in an attractive gravitational way. Imagine our surprise when we found the universe wasn't slowing down, it wasn't even going at a constant speed, it's speeding up with time. That was a real jaw-dropper.
Astronomers discovered that distant galaxies were speeding away from us faster than the laws of physics predicted.
That is one of the most bizarre things you can imagine. I know it doesn't sound like much, but imagine holding a rock in front of you and letting it go, and instead of falling down, it falls up. That is as big of a shock as what the astronomers got. We did not expect the universe to be accelerating its expansion.
This is one of the times that in my lifetime as an individual scientist, everything was just tilted upside down. I can tell you, nobody expected the answer to be that the universe was speeding up, that something was actually adding energy into the expansion of the universe. Nobody expected that.
Astronomers suspect a mysterious force is at work. Dark energy.
Dark energy is what we think is pushing the universe apart, causing this accelerating expansion. And the origin and true physical nature of dark energy is a big mystery.
Thanks to dark energy, more and more galaxies are crossing the cosmic event horizon and leaving the observable universe. These galaxies are lost to us forever.
There are galaxies that we can see today that in a few million years, say, we won't be able to see because the edge of the observable universe has basically moved in closer than that galaxy. That's going to happen all the time. And in 1 trillion years or something like that, all these galaxies that we see in our sky will be completely invisible because they'll be beyond the edge of the universe.
So eventually, every last galaxy will be so far away from us that light cannot reach us through that expanding space. It's almost as if you're driving through a dark desert in your car, and the very, very last town that ever exists has gone over the horizon, and there'll never be any light again.
We can see less and less of the universe as we go into the future. What a strange thought. So that means we should build all the telescopes we can now.
There's a limit to the universe we can see, even with the most advanced telescopes. But what lies beyond is one of the biggest mysteries in astronomy. The greater universe could be stranger than our wildest imagination.
When you stand on the beach and you look at the horizon and you kind of think, oh, what beautiful lands are there beyond the horizon, things I've never imagined before.
It's so natural, it's so human to ask what lies beyond that. What is the true extent of the universe?
The observable universe contains trillions of galaxies. It's about 92 billion light years across. But astronomers believe this isn't the full extent of the universe.
What we don't know is how much of the universe is our observable universe. It could be a tiny microscopic speck of this much more vast universe. We just don't know.
We have no idea how much stuff there is outside the observable universe, but because, by definition, it's outside the observable universe, we really don't know right now.
So what is out there? One theory is that space outside the observable universe is pretty much the same as our own cosmic neighborhood.
It's just more universe. It's just like here. It's just far enough away that we can't see it. So it's not like there's bizarre places where time runs backwards or aliens have two heads. Well, yeah, maybe.
But further out in the deepest parts of the greater universe, all bets are off.
We expect that as you go sort of twice or 3 times beyond the observable universe, it's probably very similar to the universe we inhabit. But if you go 1,000 times or 1,000,000 times farther, who knows what you might see?
It might be very, very different if we go far enough away.
Strangely, it all comes back to the expansion of the universe, and one crucial detail in that process.
There was a brief moment in the very early history of the universe where its expansion accelerated hugely. This acceleration is called inflation, and in a brief moment, the universe itself expanded at multiple times the speed of light.
Inflation was a formative moment for our universe. By the time it stopped, the universe's basic characteristics were set.
There are these fundamental constants that describe the phenomena in our universe, the fundamentals of matter and light and space-time.
But some scientists think there could be regions of the greater galaxy where inflation has never stopped.
The idea is the greater universe is expanding at an insane speed, but here and there, occasionally, a little region will stop inflating and just expand at the normal rate.
Inflation can end somewhere, and that gives rise to the universe we live in, while inflation continues somewhere else.
Parts of the greater universe that continue to inflate would be left with different laws of physics.
These incredibly violent inflation processes actually monkeyed with the very fabric of space itself, so that a lot of the things that we were taught are laws of physics are different there.
So in essence, inflation gives us a very natural way to make this patchwork quilt of different parts of the universe where things seem different. So what we can imagine is a super large-scale structure where there's different regions of the universe, domains, and each domain has different local laws of physics.
These different parts of the universe are separated by frontiers called domain walls. We have similar boundaries on Earth.
Whenever you have something that can be in many different states, you can end up with domain wall. If I were a fish swimming around in the Arctic near an iceberg, there would be a domain boundary between the water being in the liquid state where I am and the solid state inside the ice. So a domain wall is just the wall between 2 domains. If it's water, this could be ice, this could be liquid. If we're talking about space, this could be a kind of space maybe you can live in. This could be the kind of space where you don't want to be.
Crossing a domain wall would be very bad news for anyone who dared to try.
Cross that domain wall and the laws of physics could change dramatically. The number of dimensions could change.
If we were somehow able to travel to places in the universe where the laws of physics are different, we would die. Because all of the chemistry going on in our bodies depends very, very sensitively on the laws of physics.
So you could just dissipate like Thanos snapped and you're gone.
Domain walls might be the closest we get to locating an edge in the universe.
Depends on how you define the edge. If it is the realm where the laws of our universe operate, then these domain walls are in essence the edge of the universe.
But this is all just theory.
If we ever really are to work out what the true size and shape of the universe is, we're going to have to look for clues that are close to us.
Clues that could answer the ultimate question. How big is the rest of the greater universe? And could it go on forever? For tens of thousands of years, mankind has gazed in wonder at the vastness of the cosmos. But just how extensive is it? If we could answer that question, it might help us to understand our place in the universe.
One of the fundamental questions in science is, how big is the universe?
To answer the question, how big is the universe, we have to answer the question, what shape is the universe? And by shape, I mean geometry. I mean, how is the universe curved on its larger scales?
If we were to discover that the universe does have some sort of geometric curvature, then this might imply that it wraps around in on itself over incredibly large distances, and that if you could travel in one direction long enough, you would end up at your starting point.
Another version is that the universe is more like an infinite flat plane, okay? No curvature at all. The further you travel, well, the further you get, and you never get back to where you started.
To work out the shape of something, we would normally just step back and take a look. But clearly, moving outside the universe is a non-starter.
We can't jump in a rocket and fly 1,000 times larger than our cosmic horizon and see what the shape of the universe is. We just can't do that.
Our human perspective on the larger universe is so limited. So if we want to figure out what the larger shape and scale of the universe is, we're going to have to be very clever indeed.
One way to be clever is to think of the geometry of the universe in its simplest terms.
When we talk about the geometry of the universe, we really are talking about geometry. In order to do geometry, you have to take measures. You need a cosmic ruler to do this, and it turns out there's a great cosmic ruler known as baryonic acoustic oscillations.
Baryonic acoustic oscillations are ripples in the cosmic microwave background, the oldest light in the universe. As the universe expanded, these ripples were imprinted in space in a uniform way. They provide a cosmic ruler to measure vast distances over time, so we can gauge if the universe expands in curved space or over a flat plane.
When we use these cosmic rulers to try to back out the shape of the universe, we're sure to a few % accuracy that the universe is flat.
If the universe is flat, we could set off into the cosmos and continue traveling forever. There may be no edge to our universe, because a flat universe can be infinite.
Now we're thinking of the universe as something that really does go on forever, that the stars and galaxies never have an end. And how can something truly infinite really exist?
Infinity is weird because it's a concept of, because it's endless. What does that mean? Who knows? I don't know.
Infinity is a concept more than anything else. Our brains aren't evolved for that. We evolved living in the plains. We were apes, looking for food. You know, we weren't evolved to think about the universe and all of this stuff.
I just can't stop contemplating this stuff. The idea of infinity and these large numbers and even the tininess of everything. It's nuts.
Yeah, thinking about infinity makes my head hurt a little bit.
A particularly bizarre property of the universe that's infinite in space is that extremely rare events aren't just likely to happen, they're guaranteed to happen.
Impossible coin flips become possible.
If you have a fair coin, right, there's a 50% chance you flip it, it'll be heads. 25% chance you'll flip it twice in a row and it'll be heads both times, it becomes less and less likely to get an infinite or a very long sequence of heads again and again. But if the universe is infinitely big, every possible sequence of coin flips has happened somewhere in the universe. Even a perfectly fair coin, not a cheat, not a magician trying to fool you, has been flipped 1,000,000 times and it came up heads every time. If you were that person flipping that coin, you would be baffled, you would be convinced someone was trying to cheat you, and you would be wrong. It's just unlucky to be the person who sees this dramatically unlikely thing.
An infinite universe has profound implications for understanding our place in the cosmos. It guarantees we are not alone.
But if the universe is infinite, then there could be an infinite number of galaxies that have planets with life, an infinite number without life. Then because life did appear here on Earth, it's physically possible, therefore it will definitely happen elsewhere in the universe.
In a flat universe, alien life could come in an infinite number of forms. But there is an altogether stranger guarantee.
If the universe has no edge, this means that things that seem like they are impossible become possible.
Every possible arrangement of matter, every possible history of a galaxy, of a solar system, of a planet like Earth is possible and is happening right now in parallel to us somewhere over there.
So that means that there has to be another place that has a galaxy just like ours, and it would have an Earth just like ours. It would have people. It would have another version of you, another version of me.
It's 100% guaranteed that there's another Max Tegmark out there having exactly this conversation, and in fact, many of them.
An infinite universe full of Max Tegmarks may be a strange concept, but what's truly mind-bending is understanding the physics of a flat universe. If the universe is infinite and it's expanding, what is it expanding into? And what did it expand from? And was there ever an edge to the universe?
Fortunately, the answer is that it doesn't make sense to ask that question. Everything is expanding, including the universe that we exist within. So, in fact, it's not expanding into anything because it is everything.
To help understand what's going on in an infinite universe, we need to go back to the Big Bang.
We want to think of the Big Bang as an explosion in space, like it happened someplace. But there wasn't any place before the Big Bang. Space existed inside of the Big Bang itself. So it's not an explosion in space, it's an explosion of space.
We're sometimes told that at the Big Bang, the universe started out very, very small and then got big. But how can a finite point become infinite? Well, if the universe is infinite, then it was also infinite at the Big Bang. And this is a tough thing to think about. Think about it this way. In an infinite universe, the galaxies go on forever, and now there's a great distance between every galaxy. But once upon a time, the galaxies were closer together, say half their current distance apart. But they still went on forever. The universe was still infinite.
In a flat universe, space was infinite from the beginning. There was never a single point in space where the Big Bang happened. It happened everywhere. An infinite universe offers infinite possibilities, but no edge to space. But there may be another kind of edge, one that will only reveal itself if the universe dies. We live in an infinite and expanding universe. Space has no edge. It goes on forever. But there could be a different kind of edge to our universe. An edge of time.
The universe seems to have begun 13.8 billion years ago in the past, so there's some inclination, some impression that it's finite in time.
What we call the Big Bang is, as far as we understand it, a beginning, a start of the universe. The universe has a finite age. Now, does it have an edge in the future?
We used to think that time would someday come to a catastrophic end, along with the planets, galaxies, and all life in the universe.
If we know there's a Big Bang, if we know the universe started, expanded, and cooled, it's very natural to wonder whether or not someday the expansion will stop, reverse, and come back. And that's a big crunch.
In a big crunch, our expanding universe will begin to contract. Stars and planets will smash into each other. Galaxies will collide. And all of the life left in space will be compressed with all other matter into a singularity. If this theory is true, then the universe will have a beginning and an end of time.
If we live in a universe that will expand, stop expanding, and then go back into a crunch, then it has, in effect, two edges.
But there's a much stranger possibility.
Perhaps the end is but a beginning. Well, the universe is an oscillating universe. It has a Big Bang-like beginning. It expands to a maximum size and then goes back into a big crunch and does that over and over.
We could be residents of a universe created from the ashes of another. A single universe in a stream of bouncing universes. Each full of galaxies, planets, and life. But our most recent observations of the universe suggests a big crunch isn't in the cards. Once again, dark energy is key.
Dark energy really is little more than a word for our ignorance. And until we can figure out more about what this stuff is, we will not know our ultimate destiny and whether things are going to keep flying apart or come crashing together or what.
But most scientists think a big crunch is unlikely.
For a while, we didn't know if the expansion of the universe was going to slow, stop, and reverse itself because of gravity. There are all these galaxies in the universe and they're pulling on each other by their gravity. And if the expansion isn't fast enough, that gravity might be strong enough to stop the expansion and recollapse the universe. Now, with dark energy, we know that there's no way that can happen. The universe is going to expand forever because dark energy is pumping it full of acceleration.
In order for there to be a big crunch, our understanding of dark energy would have to change a lot. That is, dark energy would have to be extremely weird and turn off in some very funny way for the universe to suddenly stop expanding and recollapse.
Without a big crunch, there is no future edge to time.
The universe is not only expanding, but it's being driven by dark energy to expand faster and faster. And the dark energy doesn't dilute away, as far as we can tell. So the simplest idea is that the universe will simply continue to expand eternally toward the future.
Just like space, time would go on forever. It may sound like a better fate for life in the universe, but it's not.
One of the consequences of this dark energy that's causing the acceleration of the universe is that we eventually are headed towards the big chill. I should say we're eventually headed towards the big chill. So the universe is getting colder and colder, and things are getting more and more spread out.
So the accelerated and continual and forever expansion of our universe might make for a frankly depressing end to time itself. The ultimate entropy-based heat death of the universe, where you would walk out and see no stars in the sky. See absolutely nothing. There will come one day when the very last star in the universe just fizzles out, and that is it.
In the future, space will be a cold, dark, infinite void, where time goes on forever. There will be nothing to do but suffer in the eternal expanse. It's our inevitable fate if there's no future edge of time in the universe. But even if there isn't an edge to the universe, could there be edges within the universe?
If you wanted to visit the edge of the universe, then go find your nearest black hole and jump on in, because that's a one-way trip.
If you cross this edge, you will never return. April 2019, an international team of astronomers makes a special announcement.
And we are delighted to be able to report to you today that we have seen and taken a picture of a black hole. Here it is.
It's a picture of a supermassive black hole at the center of the M87 galaxy, 54 million light years away. It may also be the first image of an edge in the universe.
Black holes create a really interesting scenario when we think about space and the universe having edges.
This edge between space outside and inside a black hole is called the event horizon.
The event horizon of a black hole is a region within which, once you cross inside, the gravitational tug is so strong that even light cannot escape, which means nothing can escape once you cross inside the event horizon. So that really is sort of an edge, because it really does create a boundary.
The event horizon isn't a physical barrier in space.
The event horizon is an edge of the part of the universe we can visit. But it's not an edge in the sense that there's anything there. You would just pass right through it if you actually got right up to that place. So it's sort of a conceptual boundary between two different parts of the universe.
If we did send a manned probe to a black hole, it would be a one-way trip.
The event horizons of black holes are a sort of edge, because once you pass through an event horizon, you are cut off from the rest of the universe. You can never go back out. You are outside of our universe.
Once you've crossed inside that region, you are never coming back out, and that's an edge.
Once inside the black hole, the probe would be in a separate part of space, cut off from the rest of the universe.
Falling through the event horizon of a black hole is like jumping over the edge of a cliff. You can see the edge, and you can see the edge go by, and then when you're at the bottom, you can look up and see what's happening at the top of the cliff, but you can never go back.
At the bottom of this black hole cliff sits a singularity, a region of space where the laws of physics go off the rails.
Deep toward that singularity could be as surprising as you might imagine, and yet still a possibility.
If you map the space-time around a black hole in a very particular way, there emerges a sort of mirror universe, a parallel universe on the other side of the black hole, identical to our own and traversable via the black hole.
So black holes are not just edges to our universe. They may also be gateways to other universes.
It's highly conjectured, but if there's ever going to be a space or a region where you're making connections with, say, some other universe, a black hole in principle could be a portal to that.
But it's highly unlikely anyone will ever want to venture beyond an event horizon. And our pursuit of the other edges in the cosmos offers little hope. We can never travel beyond the cosmic event horizon. and we will never be able to see beyond the edge of our observable universe. So can we ever hope to discover the true edge of the greater universe, or find out if it even has one?
My feeling is that probably we should not think about edges for the universe. Everything you've ever seen in your life is finite. It has an inside and an outside. It has an edge. The universe might not be like that. It's probably not like that. There's probably no sense in which the universe has an edge.
We used to think that the ultimate limits on the future of life were set by nature. We couldn't get off the planet, or there was nothing beyond our solar system. Now we realize we have this vast, vast cosmos out there, and that the ultimate limits are actually simply our own imagination and our ability to do great things with it rather than self-destruct. Our future destiny is in our own hands, and I find that very empowering.
It is beautifully frustrating to realize how limited we are, to realize that we're probably never going to get a true view of the real extent of the universe.
We should keep an open mind, we should be humble, but I think that we should give up on the idea that things should have edges because that's what we're familiar with. The universe is something special.
What matters to us, and will only ever matter to us, is the observable universe, because that's the limit of what we can see, and that is the limit of what we can know. So there is an edge to the universe. There's an edge to what we can know.